In 0.6a, we're going to deal with a concept that I don't think you learned last year at all. And it has everything to do with these exponents, but what happens when the exponent is written as a fraction? These are called fractional exponents, and there are two different forms. When it is written like this, where you have k to the 3/2 power, this is called exponential form. You're writing things as an exponent. When you switch it from exponential form into this thing with the radical symbol, it is called radical form. And your job will be to know that the top, the numerator of any fractional exponent is the power. This is being raised to the 3rd power, just like this 3 is outside or inside of the radical. The over 2, that bottom number, is the root, or your square root. You're taking the square root in this case, which in math, this is the only invisible 2, so you don't need to write that little 2 in this problem. So for number 3, your first example says, we'll write this in radical form. You would take this k to the 3/2 power, and you would know that the root is the bottom number, and you'd be taking the second root, otherwise known as the square root of k to the 3rd power. This is how you would write it in radical form. The way that I remember which piece is which piece is I remember that trees. Let me draw my tree. Yay! I don't know why I draw trees like this, but I do. I think of a tree that's growing, and I always think about the roots of trees grow down, and this is your root. This is which root it is. It might be a 3rd root or a 4th root or a square root. You would do that as well. But if it was a square root, it would look like this. There you go. I've never seen a tree like that, except once near a river. I'll show it to you sometime when I find it. Okay? So there you go. That's a square root. There you go. Next thing you know, write the expression in exponential form. This is in radical form. We need to convert it over into exponential form. Number 6. The hardest part, the reason why I chose number 6 is because some of you will know that this is the square root and that this is being raised. We have one group of them. But you have to realize that the 2x is inside the radical, meaning the whole group is. So when I write this in exponential form, I have to remember that I have 2x being raised to the 1/2 power. I would accept this as the answer for number 6, or I would also accept this as the answer. They are equivalent. But what you cannot have as the answer is you cannot just have 2x to the 1/2 without the parentheses, because the entire group is underneath the radical. I hope that makes sense. Now, the majority of your problems will not be converting from exponential to radical form and radical form to exponential form. The first few problems are basically like that. But the majority of your problems will look like 10, 15, 18, and 23. I think 23 is a nice example of what you can expect on a quiz or a test question. But let's start you off with the basics. If I were to ask you to simplify this, your job will be to know how to convert it into radical form and then reduce. So, when simplifying, you can choose to do the power first or the root first. I recommend making it smaller before you make it bigger. So when I'm looking at number 10, the first thing that I do for number 10 is I know that this is my root. I'm taking the square root of 9 to the 3rd. You have a choice. You can either do the root part first or the 3 part first, and you'll get the same answer either way. Because I've been trying to show you or emphasize taking the shortest road possible in math problems, the shortest road will be, if you can make it smaller first. So let me show you something. I'm going to cover up this right here, and 9 to the third, does that make it smaller or bigger? Okay, and let me cover up the 3. Does that make it smaller or bigger? And can you take the square root of 9? Do you know what the square root of 9 is? Does it come out nice and even? If it's so, then let's do that part first. Let me circle this. Can you do that first? What is the square root of 9? I bet you know what it is.
3.
And then you still have this exponent to deal with for that group. 3 to the third. And I bet you know what 3 to the third is. Your final answer would be 27. Now, just to show you, you have options. Let me show you some longer roads that get you the same answer. Just for kicks and giggles. You don't have to write this down. Just watch. What if you did 9 times 9 times 9, and then you took the square root of that? Could you have done that? Sure. You're making it bigger. That's fine. You'll still get the same answer. Let's factor out a 9, because you need 2 of them. And then a 3 and a 3. Nothing's left inside. 9 times 3, 27. Same answer. Just slightly more work possibly. Okay? Not that much longer. What I do not recommend is you do 9 times 9 is 81. Times 9 is 81 times 9, 729. And then breaking it apart. That's a lot of extra work. Okay? Number 15. Now we have a negative exponent. So let's apply what we remembered from last time with negative exponents, and let's also apply rationalizing and everything else. 16 to the negative 3/2 power. To make this positive, it moves it to the denominator. 16 to the 3/2 power in the denominator. That's what we learned or reviewed in the previous section. And then we learned in this section that bottom number is the root and the top number is the exponent. So we're going to have to rationalize this, but the easiest way to do it is going to always be make it smaller if you can. So you can do the third exponent first if you want to, or you can do the square root of 16 first. Which one's going to be easier? What's the square root of 16? When you do this part first, that little 3 stays there, and you do that 4, and don't forget about that 3. If you don't know what 4 to the third is, you can plug it into a calculator, but 4 times 4 is 16 times 4 is 64. Is it rationalized? There's nothing in the square root in the denominator. You may end up having to rationalize some of these just like you did in previous sections. So that's how it gets harder or more difficult. Number 18. First thing I'm going to do for number 18 is I'm going to move, since this whole group is to the negative 2/3 power, I'm going to move the whole group to the denominator. 1 over whole group negative 27 to the 2/3 power. Then what I'm going to do is the bottom number is your root. Third root of negative 27 in parentheses squared over 1. Now, you may not have been asked this before, but I'm going to ask it to you right now. Third root. can I do a negative times a negative times a negative? Does that make a negative? So when you see these three factors and there's a negative, do not assume that it's no solution. That it would only be a no solution if it was the square root. Because this is an odd number and we have a negative there, we can pull out negatives here. We can pull out a negative 3 times a positive 9. We can pull out a negative 3 times a negative 3, and I can factor out a negative 3 from this whole thing. That little square doesn't go away because we haven't done it yet. But what is 1 over negative 3 times negative 3? That gives us our final answer, 1 over 9. There are other roads you could do, and you can still get the same answer if you decided to do the square first, which would have been fine. (23). I'm going to take the fourth root of all this to the third power. So the whole group is to the 3/4. So I'm going to do the fourth root of all of this, 16a to the 4th, b to the 8th, all raised to the third power. The bottom number is your root. The top number is your power. The good thing is we've had lots of practice with this so far. We have done this where we've done 2 times 8, 2 times 4, 2 times 2. Do I have 4 factors? Do I have 4 factors? Do I have 4 factors for the b as well? When I look at all these, the 16 has to have 4 factors. The a has to have 4 factors. The b has to have 4 factors, and they all do. So we can do all this first and then the 3. Let's simplify. The fourth root of 16, I bet you know what it is. And the fourth root of a to the 4th and the fourth root of b to the 8th, I bet you know what it is. Please tell me what it is out loud. The first number is what? Say it out loud.
2.
The first letter is what? Say it out loud.
A.
And the next letter is?
B squared.
Good. Now that is a group. I'm going to put it in parentheses to the third power because we didn't do that third exponent. That third power applies to the b squared. It applies to the 2. It applies to the a. So don't forget to do 2 to the 3rd, a to the 3rd, and b to the 6th because you're multiplying those things. Our final answer should be 8a to the 3rd, b to the 6th power. Last example. Find the value of x. Then there's these problems at the very, very back of the worksheet, and I like them a lot because they really test whether you know your rules of exponents and fractional exponents, and we can figure out what x is and go from there. So this says the 5th root of 12 to the 3rd times the 5th root of 12 to the 8th is equal to the 12 to the what over 5 power. So let's simplify this first. The first thing I'm going to do is I'm going to take this radical and I'm going to put it into exponential form. This is the same thing as 12 to the 3/5 power. I put the root on bottom. The second thing I'm going to do is do the same thing for the second radical. I'm going to put it in exponential form. This is the same thing as 12 to the 8/5 power. And now we have this times that. When we multiply two things with the same base, I know that the rule says if they have the same base, you can just add their exponents. So I'm going to do 12 to the 3/5 power plus 8/5 to see what that is equal to. Actually, I know what that is. 3/5 plus 8/5 is 11/5. And this side is 12 to the x over 5 power. And right now, I can already tell what x is going to be equal to. 12, 12, 5, 5, 11 is in the same spot as the x. If this base is 12 and that base is 12, that means the exponents have to be the same. And so x is going to have to be the same as the 11. So I'm going to stop right there, since that's the shortest road, and say, oh, x is 11. We're going to stop your notes right there.